Good morning, Home Talks. Today we are going to talk about those characteristics of our new function, that exponential function, in the following minutes to come. You should have your notebooks out right now and go ahead and title this new page with the exponential function and write down your essential question. We will come back to this one, and I need you to tell me the major differences, not just an obvious one of what the table looks like, but what is one major difference between exponential functions and linear functions. From this table, we can kind of see where we're getting our numbers for our, I like to call it that skeleton equation, that outline equation. The base 5, because it's going multiples of 5, multiplied by 5 each time, goes right next to that exponent of x, and 2 comes from where x is 0, what is your output? That's your y-intercept. Y-intercept is where we're getting this 2 from. Remember, at any point, if I'm going too quick, pause your video, rewind it, and rewrite it down. Some examples that I would like you to write down in your notes. We're going to start off easy. We're going to look at these tables and we're going to determine if it's linear, exponential, and we're going to explain why. Meaning we're either talking about a repeated addition or repeated multiplication is where your explanation for this is going to come from. Okay, A, to go from 2 to 4, do we add 2 or do we multiply by 2? Kind of hard to tell. Let's go from 4 to 6. From 4 to 6, do we add 2 or do we multiply by 2? This one's totally add 2. This one's totally add 2. 6 to 8, we add 2. So is it repeated addition or multiplication? It's definitely repeated addition. So this is linear because repeated addition. And I hope you use complete sentences. I didn't. Improper. All right, B, 4 to 8. We can either add 4 or we can multiply by 2. Let's see, 8 to 16, definitely to go to 16, we gotta multiply by 2, multiply by 2. 16 to 32, multiply by 2. Repeated multiplication, so this is exponential because it is repeated multiplication. Again, pause your video. If you have questions throughout this video, right here is the perfect place to be writing down all of those questions on your Cornell notes. All right, let's make this a little bit harder. Evaluate each of the functions for the given value of x. What are we going to do? We're going to plug x in the equation. We haven't really done much of this, of where we're plugging it into an exponent, but I know you guys got this. This is going to equal -2 times 5 cubed. Yes, those parentheses matter because the -2 is not being cubed, just that 5 is. I'm going to expand this out, so -2 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Negative times positive is negative. 2 times 5 is 0. 2 times 2, sorry, 10. Yeah, carried my 1. 2 times 2 is 4. Plus 1 is 5. 2 times 1 is 2. Negative 250. All right. Ooh, we're going to switch it up and go with a decimal. What are you going to do? I hope right now you're thinking in your head, substituted for that exponent. Remember that x is called the exponent, but the whole thing, that 0.5 to the x, is called a power. 3 times 0.5 to the -2. Interesting. -2. I know we haven't talked much about this, but we will get into this more. So I'm going to go ahead and just change this to a +2 because I know we haven't talked about it, and we'll go over it next. Okay, this means 3 times 0.5 times 0.5 0.5 times 0.5 is 0.25. 3 times 0.25. I can't do off the top of my head, but if you can, you're rocking it. 3 times 5, 15. 3 times 2, 6, 7, 0, 2 decimals, 0.75. Again, sorry for the quick change right there. I know we haven't gone through negative exponents, but that will come up next. Ooh. Again, going too quickly, please pause. Graph y equals 2x to this, 2 to the x exponent, and describe its domain and range. There is no other way that we are going to teach you this year to graph it besides using a table. Remember, your starting values that we always talk about is we want to know what's happening on the negative side of x, what's happening at the origin, what's happening on the positive. So those are the first ones you should start with. When we plug -1 in for x, we haven't figured that out, so let's go ahead and skip, and we'll come back to that. We'll skip it. 0, 2 raised to the 0 happens to be 1. 2 raised to the first exponent happens to be 2, and 2 squared happens to be 4. So we're going to graph this now. My little ghetto graph. I hope you guys are using your graph paper notebook so it looks nicer. All right. 0, 1, 1, 2, 2, 4. You should connect it because it is a continuous function. The equation tells you it's a continuous function. The domain is all real numbers, and the range is it will never get to 0, so it is 0 less than y less than equal infinity, because it will go up forever. All right, another graphing problem. This one we're going to add 3 to what was our previous graph. How do I know I'm adding 3? It tells me right here in the equation. My last graph went up to 4, so now I'm going to add 3. I'm going to go up to 7, so 4, 5, 6, 7. 1, 2, 3. Our graph from that last video, sorry, the last slide, not video, went 0, 1, 1, 2, 2, that was 3. Oh, I can't erase. 1, 2, 2, 4. Here's our one from that last video, the last slide. Dang it. Here's our new one. Again, we're going to make a table. Now let's keep it positive because I haven't taught you how to do work at negative exponents yet. I'm supposed to say y. Whew, making mistakes all over the place. 2 to the 0 is 1, and 1 plus 3 is 3, 4, goodness. 2 to the first is 2, plus 3 is 5. 2 squared is 4, plus 3 is 7. And it's okay if I don't do 3. We'll come back to it if I need it. So 0, 1, 2, 3, 4. 1, 5. 2, 7. Describe the domain and range. The domain for this function happens to be all real numbers. The range for this function happens to be the same thing. 0 less than y. No equal sign because it won't ever be 0. Less than equal to infinity. Compare the graphs. I kind of told you the answer at the beginning of this one. The purple graph is just like the blue graph, just moved up 3. All right, now it's time to try this on your own. You're going to go through and tell me if this table is an exponential or linear function and why. You're going to evaluate this function when x is 2, and you're going ahead and graph using a table, make sure you're only using positive numbers because we haven't gone over that. So why don't you just use 1, 2, and 3 and tell me the domain and range of it. All right, you should have paused your video back there. Here's what you should have gotten for those 3 questions. Go ahead and check your work, then go ahead and answer this essential question. Your next objective is to do that checkpoint on Schoology. I hope you guys have a great weekend. See you Monday.